Okay, so this is going to be the support for 2.7. We're going to start here with question number 7. We got skating stunt known as crack the whip. Number of skaters hold hands in a straight line. They spin a line that rotates around one at the end who acts as the pivot. The skater that's furthest out has a mass of 80 kilograms, is 6.1 meters from the pivot. He's skating at a speed of 6.8 meters per second. So he's feeling a lot of force as he's going around there. At the end, you kind of, get to a point where he can't hold on, and that person gets whipped out. There's that crack the whip idea. Anyway, we want to know how much force he's feeling as a centripetal force pulling him inward. And so we just take the centripetal force has to be equal to mass velocity squared over radius. Now, that is the cost of the circle. Now he has gravity pulling him down, normal force up, friction, but at the end of the day, for him to travel in a circle, that is what he has to experience. So the centripetal force, or the sum of all that stuff, has to equal his mass, which was 80 kilograms, times his velocity, which we were told was, let's find that again, number 7, he was traveling 6.8 meters per second. That's 6.1 meters out. So 6.8 meters per second, and that gets squared divided by the distance out, 6.1. Honestly, you just throw that in the calculator. There's not much else to it. When we do, we're going to get our 606 newtons. So there's not much to question number 6, which this was, or 7. Oh, that's a 7. There we go. Not much to it besides just understanding that when you want to calculate what the centripetal force has to be, we just say Fc equals mv squared over r. Now, normally when we do these problems, we have to add up a bunch of different forces. In this case, just, hey, what would a total have to be? So let's go ahead and look at question number, I think I'm going to jump to 11. It says, what's the ideal banking angle for a gentle turn of 1.2 kilometer radius on a highway with a speed of 105 kilometers per hour, about 65 miles an hour, to be able to make this work. Now, I'm going to tell you, traditionally when we do these, we know that obviously the tangent of theta equals v squared over g times r, if I have that all right. That's basically a formula that's a combination of a few different things, a few different formulas on the way. And if you're not sure on these formulas, oftentimes you'll find them right up here. So there's your v squared over r times g. Remember that stuff is there for you. And we're just really using this formula to solve for that angle. Okay, and so really we're looking after theta. So we don't have to worry about cars sliding off the road when it's icy or there's other conditions to worry about. And so we have the tangent of our unknown theta will equal the velocity. Now here's where we run into a little bit of an issue. The velocity is in kilometers per hour, and gravity is in meters per second squared. We have to make some conversions here. And so if we look at if we look at our information on 11, it's 1.2 kilometer radius. Well, that one's not too bad. Let's erase that real quick. Okay, the radius isn't too bad because we can just turn that into meters. So the bottom of this fraction is 9.8 times, instead of 1.2 kilometers, we're going to say 1,200 meters. Okay, it's that velocity that's an issue. And if the velocity is 105 kilometers per hour, we've got to convert that into meters per second. And so a kilometer, remember, is 1,000 meters. So we would times by 105 kilometers per hour. We would times by 1,000 meters over 1 kilometer, because that'll cancel our kilometers. But then we have to times by 1 hour over 3,600 seconds. And so when we grab our calculator to do that, there we go. We take our 105 times 1,000 divided by 3600. We end up with 29.17. We'll go there, 29.167 meters per second. And that number is going to go right here, 29.167 squared over our 9.8. I'm going to go ahead and I'm going to square this number and get an answer. I'm going to divide it by parentheses 9.8 times 1200, because that's our gravity and our radius, curvature, and we get 0.072. So this means that the tangent of theta equals 0.072 dot dot dot. To find theta, we take an arctan or tan inverse, and our calculator can do that for us. Second, tan, I just select the information above. Always, make sure that you have checked your mode. I'm in degrees. Press enter. I get 4.14 degrees. Now, for sig fig purposes, it looked like everything was a couple of sig figs. One more time, looking for it. Number 11, we had 3 sig figs, and so I lost my number. 4.14 degrees. The other problems on this assignment are still going to use that formula. They're just solving for different stuff. So hopefully that's enough to help you get through and answer the questions that you have. Good luck.